Homework 4.4, Exponential and Logarithmic Equations, Video 1. Homework due Friday, May 29th at 11:59 p.m. The following video is associated with questions 1 through 4 on this homework. In this last video in Chapter 4, this last homework in Chapter 4, but not the last homework on Test 4, there will be one more homework assignment from Chapter 5 on that test. But in this last homework from Chapter 4, we will talk about solving exponential and logarithmic equations. For those of you going towards calculus, you are expected to be able to solve these types of equations without being retaught how to do it. You might be reminded, but they won't take a whole lesson to teach you how to solve these. As the name of the section implies, there are two types of equations we'll be seeing: exponential, so equations that have exponents like this one, and logarithmic, equations that start out with logarithms. But what's not stated in the title is that there are two types of exponential equations we'll be solving and two types of logarithmic equations we'll be solving. My plan on this video is to show two examples of each type, so in total there should be 8 videos in this section. The first type of equation we're going to solve is an exponential equation, but we're going to use equal bases. In some exponential equations, you can make both sides of the equation have the same base. For example, the base on the left side of this equation is currently 6, but the base on the right side is currently 216. I can call it a base because it has an implied power of 1, and hence it's a base. Now, currently these bases are not equal. But when you're solving an exponential equation, you should ask yourself, can I get equal bases? Which usually means rewriting one or both base as a power of a new number. Now, I can't write 6 as the power of a smaller number. I can write it as 2 times 3, but that's not the power of a smaller number. So since I can't rewrite the 6, maybe I can rewrite the 216. Let's divide off some 6s and see what happens. Having a calculator handy here is a good idea. 6 will go into 216 exactly 36 times. Well, that's convenient because 36 is 6 times 6. 1, 2, 3. 216 is 6 to the 3rd power. That means, yes, I can rewrite this equation using equal bases. The left side is just going to stay 6 to the 4x minus 1, whereas the right side is going to be rewritten as 6 to the 3rd power. Now, why is this advantageous? Well, your instincts might say, let me just cancel the 6's. And you would technically be right, but I want to make sure you know the reason why you can cancel the bases. This goes back to recalling the fact that exponential functions are one-to-one, meaning that their graphs pass the horizontal line test. And what that means by definition is that if 2 inputs produce equal outputs, then the inputs had to be equal to begin with. So how does that pertain here? Well, if you'll notice, both of these are powers of 6's. And the fact that we're going to capitalize on is the fact that the function f of x equals 6 to the x power is 1-to-1. Now the stuff I'm writing in blue right now is what we're thinking. What we'll actually do, I'll shift back to black. So what we're saying here in this equation with this function is that f of 4x minus 1 is equal to f of 3. Because if this is our function, then this is f of 4x minus 1, and this is f of 3. But being a one-to-one function means if your outputs are equal, then your inputs are equal. So 4x minus 1 and 3 have to be equal. And that concludes the thought process that leads to the next line. What it essentially looks like from here to here is that you cancel the bases and you equate, which means to set equal to, the exponents. And again, the reason is because exponential functions are one-to-one, but in practice, when you're doing this, it is perfectly acceptable to go from here to here. Just remember, this is the reason why. Well, this is suddenly easy to finish. I have 1x and I just have to strip it down. Add 1 to both sides, we get 4x is equal to 4. Well, that's convenient, because now if I divide both sides by 4, I get x equals 1. So if you can rewrite an exponential equation using equal bases, then you can basically cancel the bases and equate the exponents and then solve the remaining equation. We'll take a look at one more example where we can get equal bases, because I don't want to lull you into the misconception that I only have to change one side's base. That was quick.